Thank you, everyone, for coming to Fantastically Bad Apex Automations and how to avoid them. Patent pending on the title. For anyone who doesn't know me, my name's Amnon. I'm a 15 times certified developer. Woo! I can make it 16 if I do that new cert, right? The associate one. True. This is my 4th year as an MVP. If you vote for me for one more year, I think I get into the Hall of Fame. No, you need to do something special to get a golden hoodie. My day job when I don't write sessions is with building an app called Asynchronous, where we do resource management, workforce management, field service, all sorts of stuff like that to do with dates and times and managing people. But today is not about me. I want to introduce to you a new colleague of mine who is going to deliver the session. This new colleague of mine is someone I hired recently who's come on board as part of my development team. And he's standing right out there. I think he's a bit shy. Can you come over? Can you come over, please? No? Hold on. Let me go get him. Be right back. Hi, everyone. Woo! My name's Kent Code. Gonna tell you a bit about myself. I'm a Java developer. Got 5 years of Java. Yeah, I used to build apps on mobile phones. If you ever used Nokia Fit, I built that for the N97. Woo! I moved to Salesforce development about 3 months ago. Doing great. All my Java experience is coming in really handy. And don't tell anyone, but I am building the next Facebook. Anyway, I'm going to tell you a bit about myself and what it is that I do, right? I got a whole thing here that you're probably expecting from me by now about what it is that I do on a day-to-day. So here's a little bit of intro. Wake up, get to work. I'm a developer genius. Grab my keyboard when I log on. I'm gonna write some triggers before I start. I brush up on the latest patch. Then I ignore whatever's there and write it all from scratch. I'm talking nested loops in my codes, sharing in default modes, ignore all exceptions thrown. For every record I write a query, update them individually. Look at all my hot-coded IDs. Don't stop, run more up till the database blocks. Go out, network thread on the synchronous thread. Tick tock on the clock, make the CPU block when I go. Don't stop, run more up till the database blocks. Nested loop, might as well add some SOQL. Tick tock, triggers rock. Hope my records don't block when I go. Ain't got a test in my org, but it ain't no fuss. Cause when I need to up my coverage, I just I plus. And now my users lining up as their tickets get older, but I just redirected them to go into my spam folder. I'm keeping every item in the heap. Memory is always cheap, and my stack is unbelievably deep. Don't really see the need to bulkify. They can save records one by one. Save them one by one. Save them one by. Don't stop, run more ops till the database blocks. Go out, network thread on the synchronous thread. Tick tock on the clock, make the CPU block when I go. Don't stop, run more ops till the database flop. Nested loop, might as well add some SOQL. Tick tock, triggers rock, hope my records don't lock when I code. And now it's time to take it live. We're going live on a Friday. I'm pretty sure I told everyone. If not, they'll find out on Monday. Yes, now it's time to take it live. We're going live on a Friday. I'm pretty sure I told everyone. Did I? Whatever. And my holiday's booked for all of next week. Don't stop, run more up to the database flop. Go out, network thread on the synchronous thread. Tick tock on the clock, make the CPU flop when I code. Don't stop, run more up till the database flop. Nested loop, might as well add some SOQL. Tick tock, triggers rock, hope my records don't lock when I code. Two months it took me to write that. And I didn't think about even trying it with this beard. Awful. Kent's my favorite. Right? Got hair in my mouth now there. Anyway, let's talk about automation and what bad automation precisely can do to your org. Bad automation runs when it doesn't have to, right? Everything, when we talk about automation, we're talking about something that runs after a user action. If you're doing too much when a user does something, they're going to have a bad time. It creates slow and unresponsive pages because, well, you got to do a lot of stuff in the server, right? Code is not magic. It doesn't run in the cloud by itself. The cloud is just someone else's computer, as you know. It locks records for longer. Every piece of automation that we have on Salesforce, every time we make an update, the record is locked until the trigger's finished running. So if two people try to update the same records or two different processes try to do it, the record can be locked. I'm sure you've encountered those errors before. Causes crashes because we have governor limits on CPU time, on memory, on all sorts of stuff. And, well, governor limits, more crashes. When we encounter governor limits, it's usually a warning sign. It doesn't mean Salesforce is out to get you. It means you are abusing the system resources that should be sufficient to perform whatever it is you're trying to do. When I first started with governor limits, I thought to myself, why in the world am I not allowed to make one query for every record that I need to fetch? Because I came from Java, and over there in Java, and you had some kind of local database sitting in the office, and using network traffic was absolutely not a problem. And then suddenly you come into Salesforce, and you realize you can only make X amount of queries per transaction, depending on the context. Why in the world? The following governor limits, if you ever encounter them, are a good warning sign that you have something wrong with your code, not with Salesforce. For example, CPU time and heap size, you're using too much processor time or too much memory. You're keeping too many things. Record locking means your automation takes too long to run. Query and DML limits means that you are abusing queries. You're running them inside loops. The 50,000 records queried, what kind of operation are you running that requires getting more than 50,000 records in one go? And of course, non-selective query, if you see that, that's a limit around querying an object in a trigger that has more than 200,000 records where your query does not use indexed fields. So if you ever see non-selective queries, and that happens in flows as well, by the way, it means your query is not efficient enough. It's using unindexed fields, and the database, which again is not magic. You don't just say to a database, get me all these records, and it just does it instantaneously. The database needs to work too. So if you see this kind of error, this kind of governor limit being hit, means you gotta go a bit easier on the database, help it by using indexed fields in your query. And if you can't, make indexed fields. I can tell you from experience, I work a lot with dates and times, as I said, and those can't be indexed. What I've done was create number fields that represent the same dates that I'm working with. Number fields can be indexed by marking them as external IDs. Voila, you have an instant index, a numerical index. Now, the difference between bad automation and good automation is that good automation is fast and it doesn't do things that it doesn't need to do. When you write good automation, the users are happy because things go fast. They don't have to wait 5 minutes every time they click save on a record, only to get some exception that something went wrong and then have to try it again. It also allows you to make bulk operations. If you ever tried importing data and you tried importing 200 records and it failed, in batches of 200 and it failed, why is that? It's not because Salesforce doesn't allow updating 200 records at a time. It's because your automation is too slow to process 200 records at a time. It handles exceptions, so you don't always have to pester the user with things the user doesn't need to care about. Only pester the user if there's something they need to do about it. And of course, it respects governor limits. So Kent provided us some code samples that we're going to review. And the first one is about, let's see. Oh, I like this one. It's a trigger that appends the client name to a case subject because that's what the business needed. We're going to see how Kent wrote that code, okay? Check out my awesome code. No, I'm not going to put that beard on again. Too much hair in my mouth. Yes, so this is a very innocent looking case trigger. It runs after insert. If anyone can't see the code, I'm going to try and kind of run over what it does. So it runs after insert. We iterate over each case in the trigger, and for each case we query the relevant account based on the case account ID. And then we append the account name to the subject using simple string concatenation, and then update the case. Who here can see a very obvious problem with how this trigger works? That's not enough hands. Right. First of all, this trigger runs after insert. As a general rule of thumb, if what it is that you're trying to build needs to update the same record that caused the automation to run, the same record that was saved, you should be running it in a before context. If that's all you need to do, just update something on that record, you run it before the operation completes in the database. Why? Because otherwise, you have to make a second trip to the database with whatever it is you want to update. If you run a trigger before it completes the insert operation, then any change you make on the case will be updated in the database in the same transaction. And as I mentioned before, database trips are not cheap. You don't have your own database server sitting here in your office just waiting for all that network traffic to come at you. Always consider database operations as super expensive for Salesforce. They hate doing them. They limit them for a reason. Then, of course, we have our query inside the loop. For each case, we are going to the database just to figure out what the account is. Instead, what we need to be doing is getting a list of accounts and querying them in one single database trip, one single query. And of course, updating inside the loop as well. So we've made our changes to the case, to let's say 50 cases inside one trigger. Now we're updating them one by one instead of putting them all in a list, sending the entire list to the database in one trip and getting it over with. Instead, we're making 50 trips, 200 trips, who knows? When you're writing trigger, always assume that some person is going to try and import 10,000 records in batches of 1,000. I'm not going to say who that person is. Can we fix it? Hopefully. We're going to find out. So this is how we fix this trigger. First of all, we're creating our trigger in a before insert context. Now, I know best practice says to separate the trigger logic and the trigger itself, but this is a demonstration. I'm not going to create a whole layout of classes here, so we're going to keep it in the trigger still. So the trigger runs before insert. Why? Because we're trying to update the same case that was created. We're not updating other records. Right at the beginning, we're iterating over our list of cases to make a list of account IDs. That goes into a set. Why did I choose a set and not a list? Because sets only contain unique values. So if I create 3, 5, 10 different cases for the same account, the account ID will only appear once inside a set, but it will appear 10 times inside a list. If I want to be efficient, I use a set. So now I have a set of all the account IDs of all the cases that I've created in the database. And I make a query right here once using the ID in operator, and I use my account ID set to get all of the accounts in one query instead of 10. What I do with this query is put it inside a map. Maps are magical, but they're not magic. They're magical. They're great. I'll talk about them a bit more later. A map lets you store a key and value pair. In this case, we are storing each account record according to its ID. So this map accounts variable will let us fetch an account by its ID later on in this trigger. After we've queried all the data that we need, we run over it a second time. Running over the list of cases is done locally on the server. It's not expensive. You're just running over a bunch of records. So we can do it twice. That's okay. We're not making 200 database strips here. All of this is done locally. It's okay to run over cases twice. This time, we are fetching the right account from map accounts using the account ID on the case variable. So if that account was retrieved from this query, we're going to get that account here into case account without an additional database trip. And now we can check, did we find an account? Is case account not null? If the account was found, now we can create that same update on the subject where we append the account name to the original case subject. Notice that we don't have to make another update. In the original trigger, we had another update here. Here we don't have to. Why? Because this trigger runs before insert, which means any changes we make to the case right now will be forwarded to the database without having to use an additional insert. Right? So I say it's fixed. Here's some quick notes about what I just explained. If you get that slide later, if you get the deck later, you can refer to that. Yeah. Sorry?
I see people taking a lot of pictures, so where can they see the slides?
We can share this. This is going to be recorded. Obviously, it's going to be on our YouTube channel. But if you want a copy of the deck, I'll put it out there.
It'll be on our success community on Chatter, so join us there. And it'll be on our Twitter, so join us there. London SFPC.
Of course, the singing is live. You only get it here.
It's recorded.
You should see my product demos. I swear to God, people go and have a demo with me, and I start singing Frozen to them.
With the beard?
No, without the beard. I actually got the beard today, literally at 1 o'clock today, because I couldn't find any on the high street. We went to a shopping center, to 2 shopping centers. We could not find the beard. I had to order one on Amazon. It's October. It's Halloween, right? You'd expect there to be beards. Whatever. Anyway, Kent decided that he can wreck my code and make it more efficient. Yes. Let's see. So let's see what Kent did here. So now he's querying. He's not making that list of account IDs anymore. Looks like he took that out. And instead, he's querying every account from the database. You joke, but you have no idea how many times I've actually seen this. And what else do we have? Yeah, that seems to be the major change. So really the lesson to take here is never query every record that you have in an object. Always assume that you have a billion accounts, right? And when you query, even if you can query that many accounts, even if you only have 10,000 accounts, everything that you get from the database that you don't need takes up room in your memory heap. So you're inching closer to that heap exception, the heap limit. So only query what you need, right? If you don't need it, don't query. Not to mention, if this runs in a trigger, which it does, you're also going to get the 200,000 records limit in a trigger, the non-selective query one. Kent's next code sample. Oh, but any questions about that one, by the way? Yeah? Excellent question. So, when it comes to databases, they kind of work like a big Excel spreadsheet, right?
Okay, now I know.
Okay. Anyone here doesn't know how index fields work and wants to hear? Yeah? Okay. No, we can go for it. Tell me if we run out of time. So imagine a big Excel spreadsheet, and it's got all sorts of various values. Let's say names of people. And if you want to find people by a last name, let's say you usually need to find a person by their last name, but you have a whole jumbled mess of names, just a big Excel spreadsheet with names and data about these people. An index would be an alphabetically sorted list of names and their corresponding row number in that Excel spreadsheet. So that if I give you my last name, Kruvy, you can very, very quickly look for K's, and from K you can find KR, and then KRU, and then very quickly you find my name. And then next to that name, you see a line number, let's say 1357. And then you know exactly which row to go to get that information. It's the same with databases. An indexed field has this easily searchable index behind it that the database can very quickly filter through to get only particular records to work on instead of going through every single record in the object. If you try to find an account by the number of employees and you have 1 million accounts, then it will go through every single account record and make that comparison. If you go with an indexed field, it will very quickly find just the right accounts that you're looking for. Yeah?
Amnon, can I ask you another question on the previous slide?
I can't stop you.
Thank you. Is there any efficiency in declaring the case account outside of the for loop, or does it make no difference?
So let's see. Any efficiency in declaring the case account outside of the for loop? Yes. So when we use the get function of a map, I mentioned maps are not magic. They're magic core, but they're not magic. The get function is actually a rather relatively expensive operation because the map does have to look through all of the keys that it has to find the right one. Whereas by doing this first, by finding that one account and creating a pointer to that first, we don't need to look through the entire map each time we want to refer to the account.
This, or were you asking about?
No, sorry, I need to clarify. What I was thinking is that if you declared a case account as an account pointer before you get into the for loop, does that make it any more efficient?
Don't think so. I mean, I've never tried it, but I wouldn't expect there to be any efficiency gains.
It's still going to allocate the same amount in the heap. Each time it's going to iterate through, it will just say, oh, I need a space for an account. I'll create it.
Yes.
And just disregard it.
Yeah, I would expect it to be something more along the compile time of the process instead of runtime efficiency.
Thank you.
Right. Next code sample from my friend Kent is assigning a task to validate someone's email address. Let's see what he wrote. I'm excited to see what he brought us now. This trigger is even awesomer. Let's see what this does. So first of all, this trigger runs after an update. Again, well, maybe here it makes sense. And what it does right here at the top is it checks whether this contact trigger ran before. Raise your hand if you've done this before in your own code. Created a static variable to make it so your trigger only runs once, even if the contact is updated multiple times in the same transaction. Liars. Dirty, dirty liars. I don't believe any of you. 3 people who raised their hands, I like you. If you have this kind of check, I can tell you straight away that your trigger runs more often than it needs to. You should not care whether your automation already ran in this transaction. What you should care about is what changed in the contact and whether that should cause your logic to run. In this case, if we're trying to validate an email address after an update, we should only do that if the contact's email address changed. Not every time the contact is updated, and only once in every single transaction. That's incorrect logic. If we restrict it, if we check, compare the old value, the old email of the contact with the new email of the contact, and see that it changed, and only then raise a task to verify that address, our trigger will be efficient. It will not run more than it needs to, and we won't need weird static flags in our code. Let's see what else it does. So here we've got this function to validate the email address, and if that returns false, we're creating an email task, an email validation task, and we're inserting it into the database. Any problem with that? Any obvious issue, Erica? That's right. We're inserting them again one by one inside the for loop, and then we're telling the system that please don't run this a second time in this transaction. Oh, another one that I completely forgot about here. We are using trigger old map to get the old state of the record. A lot of people do that, use old map to get the old record. As I mentioned before, using maps, using the get function of a map is nice, but it's not a very efficient function because a map has 100 contacts and you're searching for a particular one from that map. And no matter how efficient Salesforce can make that function work, it's not going to be as efficient as using trigger.old, which just receives a numerical index. Get me the third contact instead of get me the contact whose ID is 0030000x150. So can we fix it? Yay! This is how we fix this trigger. First of all, we iterate over the list of contacts with a numerical index, a numerical iterator, and we get the new and the old contacts from that same index. That way, no maps, no gets. We just say, get me the first contact, get me the second contact, get me the third, which is much easier for a computer to do. Just like you, human beings. If you had to do it yourself, it would be easier for you as well. Then we compare the new email address to the old email address, and only if they're different, we execute the trigger logic. In this trigger logic, we add this new task to a list of tasks instead of the database, and only at the end of the loop, at the end of all the other logic, we insert that list into the database. Any questions? Yeah? You're helping me today. Go ahead.
Yeah, I might be wrong. I think I am wrong, but just in case, I thought that when you use the for loop, it was always advised to not use with the numeric, to always do with the object. And
If we do it with the object,
then I understand what you're saying.
so that it would have been true if we didn't need to also get the old state of the record. If we just needed to iterate over the new records and we didn't care about the old ones, then using a for loop that iterates over the list directly with an enumerator would have worked fine. The only reason I'm recommending to use a numerical index here is so that we can easily fetch the old state of the record, the old contact, without having to use the get function of a map. Now, I'm not going to bore you with, n log n and code efficiency stuff that you probably learned in college and whatever. But fetching a record using a numerical index from an array or a list is much faster, much more efficient than getting it from a map that has... Depends. If you just need to iterate over a list and you don't need to get the equivalent record from another list, then maybe what you're doing is fine. Okay. If you really want to get into efficiency, by the way, I heard that decreasing the index, minus minus instead of plus plus, is actually slightly faster. But
if you do a while loop and
yeah,
decreasing, that's faster.
that's if you really want to go speed demon.
It's faster also in JavaScript. That's
Yes.
why I know it.
Something to do with how the processor does plus and minus. Anyway, maps, as I mentioned, they're not magic. They're just magical. Fetching a record still takes CPU time because we still have to iterate over a list of records and find the right one. But we're going to have a little demonstration so that you can all kind of understand exactly what I mean. Here's a list of 5 different contacts. Right? Now, I would like you all to find me the contact in row 3. What's the name of the contact in row 3? Well done. That took about, what, 1 second, 2 seconds? Right? Now, our next task is find me the contact with the ID 003-04007. Well done. But we only had one person say it out in 2 seconds. So the rest of you, we've got one machine here. Android. But imagine that table with 100 people, or 1,000. Becomes a little bit trickier, right? Anyway, the third code sample is integration with an external system. Todd, how are we on time? Good.
We don't care about time.
Good. I don't have any more musicals today. Don't. You got what you can from me. Anyway, let's see what we can find in Kent's 2-line trigger here, and let's see if we can spot any errors in this, right? Anything obvious comes to mind? Yeah? Want to share?
So inside the loop, they are making the callouts.
That's right. So just because we hid our callout inside this fancy function called integration utils update account, just because we hid it inside a function doesn't mean we're not still doing a callout, and that callout is inside the loop. Nice try, Kent, but you can't fool us. How do we fix this, though? This is much more challenging to fix because, right? Because here, keep in mind that the callout limit, anyone knows the callout limit in Apex? 100, that's right. You can make 100 callouts in one single transaction. How many records can be in a single trigger execution context? Anyone else? 200, that's right. So if we can have an update of 200 accounts in one operation, but we can only make 100 callouts maximum in that transaction, how can we fix it? So bulkifying would be a great solution, but it's also dependent on the target system. If the target system only accepts one account at a time, which is, by the way, very, very common, Salesforce has a bulk API, a composite API where you can do this, but other systems don't. Right? Yes, we got to take this into an asynchronous operation. My favorite way of dealing with it is using a queuable class, where the queuable gets some kind of list of records to process. It runs in a loop over each record, checks where it is as far as limits. That can be CPU limit, memory limit, callout limit, whatever limits you're afraid of hitting, check where you are, because you have a limits class that tells you how much you've used and what is your maximum. And once you've reached that threshold, you just take that class and put it back in the queue. And then it runs again a few seconds later and processes the rest of the records. And you can do that pretty much indefinitely. I think 10,000 times in 24 hours. Or you can run Asynchronous Apex.
But you can have only 50 queued at the same time.
No, but that's the thing. You don't queue 50. You queue one. And that one class puts itself back in the queue when it's done. And I've got a code sample. This is, it's a bit much. It's a code sample, but generally speaking,
That's so beautiful.
thank you. This is what it does, right? First of all, up here, all we're doing is figuring out what our thresholds are. So we've got a DML limit, a query limit, a callout limit, and we're using the limits class multiplied by 0.75 and basically asking what is 75% of my total allowance for each of these limits and keeping it in an integer. And then we have a while loop here that checks how many have I used, how many DML statements have I used. If it's smaller than my limit, then keep going. And if the query limit is smaller than my limit, keep going. And all the limits that I'm checking. And as long as I'm within those thresholds, pop the next item from the queue, process that record, and then remove it from the queue. And then, when we're done, go again in the while loop, check our limits again, process the next record. When we're done, when we're finished processing everything, we have this. If we still have more items in the queue, just system in queue job this. It puts the exact same class with the exact same state, meaning all of the items that are still queued, it just puts the same class back in the queue to continue later with fresh governor limits. Easy peasy. And you can take that. Obviously, I'm checking here for quite a few different limits. You can get rid of some, check only the limits that you care about. Anyway, I sent this code to Kent. And he modified it a bit and was able to get a pretty good result, right? So this is pretty much the same template. He's only checking the DML limit here, but I'll forgive him. But let's continue. Wait, hold on. What's this? What's this little bit of code right here at the end? Can you see that? It says public void run test, integer I equals 0, I plus plus. What's that? Hold on. Let me scroll down. What the F? What?
I never saw that. No, what the fuck is this?
You've never seen this?
No.
Really?
What the fuck is it?
Remind me where you work. Can I get a job there? Okay. Anyone who's never seen this code, raise your hand. Really? Never? You're all a bunch of liars.
No.
Check. Search. You will find. Search and you will find. So this is a piece of code for people who don't like writing unit tests. What they do is they make a really, really, really long function with very meaningless code, I++, repeating until infinity. And then in their unit tests, they just call this function to get their 75% code coverage. Who likes writing unit tests? Liars. Dirty liars. I can't believe it. People do it all the time.
I already done my test.
Yeah. Well, you know the old saying, if your tests don't validate your logic, you're going to have a bad time. I wish Richard was here. He would have stopped me and given us a whole new session about writing unit tests. Yes, let's talk very briefly about tests, right? Because, we got to do it. One, Other sign of bad development is not writing unit tests. So if you want to write a good test, not just get through the 75% code coverage, your test needs to have 3 phases. One where it creates test data, because tests don't have data unless you make it. Then another one where you run your logic, you execute your logic. And then the third phase is checking the results of your logic. If you don't have those 3 stages, you're not writing a test. You're writing some code to get past Salesforce's code coverage. Tests need to check for scenarios. They need to check logic, things that can happen, that users can do, and what they expect. When you write a test, your goal is not to get code coverage. Okay? If the same code handles 3 different scenarios, don't just test for one. Test for all 3. Tests also check for things that should not happen as well as things that should happen. Okay? Negative test cases are still test cases. And they should be as long, as a minimum, they need to be as long as the code that you're testing. Bare minimum. Usually, a unit test is easily twice the length of the code that it's testing. Easily. So if your test is not longer than the code itself, you're probably missing stuff. Okay?
If you have 3 scenarios, you need to have 9.
Pretty much, yes. A couple of bits, so just a summary of what we learned today. At least what I hope someone who works with me learned today. When we write automation, we want to perform operations in bulk. 1 database trip instead of 200. Query everything you need in one go. Query only what you need. Don't keep things in memory if you don't need them. Maps are our friends, but again, treat them with respect. They're not magic. Use before triggers to reduce unnecessary database trips. If you have something that requires a lot of processing, make it asynchronous. Users don't like waiting for heavy tasks to be completed. Feel free to write asynchronous triggers. Just keep in mind the limits behind it. You can only do 10,000 asynchronous Apex operations per day, so just keep that in mind. As long as it's not something that happens 20,000 times in a day, offload it to an asynchronous process. Limits are your friends, despite what you may think. They're here to guide you, not to hurt you. And of course, unit tests. Unit tests are one of those things that future you will thank you for. Do it for future you. That's it for today. And very special thanks to Kent, who ran off to spit beard hairs in the sink. I don't know. Yes. If anyone has any more questions, now's a good time. In the back?
Yeah, sorry, going back to non-selective queries.
Yes.
How do you make a field index? You need to call support, you can make the field external ID, or there's any other way you can make it?
Excellent question. The standard way that Salesforce will tell you to use is to contact support and explain to them why that field needs to be indexed. After which, they will inevitably say no. Talking from experience here, right? So sometimes you have to get a bit creative. Like I said, when I had a date field that I wanted to index, I created a number field that represented that same date as YYYY month MMDD, just as a number. And I marked that field as an external ID. External ID fields are automatically indexed. Lookup fields are always automatically indexed. Text fields and number fields can be marked as external IDs. Not every field can, but if you need to search through something and you need that trick, absolutely use it. Formulas, if you can avoid it, do not query by formula fields. Because that means that for every record, if you can avoid querying by formula fields, absolutely avoid it. Even if it means using a record triggered flow or a trigger to copy the value of the formula into an indexed field, maybe a text field that's marked as an external ID, and just so you can filter by that indexed field. Because filtering by formulas is very difficult for the database.
Yeah, because it needs to generate the data on the fly for
Yeah.
each one of them because the data doesn't exist when it's in a formula.
That's right.
Don't query by formula.
Is there any limit of index fields you can have on an object, or you can have as many as you want?
I'm not sure.
There's a limit to the number of external IDs, isn't there?
Probably.
Yeah. If you go that route.
You can have like 5.
I mean,
There is a limit.
yeah, okay.
There's a threshold past which Salesforce themselves will not go past, and they use a tool called Blacktail to actually enable it.
Well, in that case, if you do happen to reach that limit, I'm sure there are other ways of handling it. For example, you can create a custom object which serves as a kind of makeshift index for the fields that you need, maybe something with a name and a lookup to the record that you want, and then you can query by that object and get the record ID, which is, of course, indexed.
You can also have two-dimensional.
Tell me about those.
So it's an index that uses two fields in combination.
Okay. How do you make a two-dimensional index?
But yeah, you need way more justification for that than just a single index.
I mean, I know that once I've asked support to index a field in an object that had hundreds of thousands, if not millions of records, and again for a date field, and they just said no. So I kind of learned my lesson, figured out that they don't want to make indexes. And also, you have to do it if you're doing a product. If you're building a product, you have to do it on every org. You can't just put it in the package, I think. So I gave up on it and decided to go with a custom index. Anyone else? Okay, in that case, thank you all for coming.